Let's say that you want to create a trajectory for your robot, and you want to make sure that this trajectory is time optimal. Maybe you're trying to ensure that the cost of transport for your robot is minimal, and the amount of energy that is consumed for, let's say, a legged robot per stride is very low, or the amount of the amount of motor currents that are used in that particular motion are low, or the spring force for your robot is low. In all of these cases, of course, you have to figure out first if you can make a rough model of the system, and you can identify how to reduce you can apply optimization, you can use optimal controls and figure out how to minimize the amount of each of these parameters. You can do a constrained optimization. It would be much more efficient for you to use that. And what happens many a times is that people who are not familiar with optimization theory or convex optimization will end up creating a system with some baseline and say, okay, well, it operates, right? So I guess that works for me. But if you're trying to design an optimal path for a robot, then you have to have motion planning that is using these tools, like, for example, model predictive control. And it's not just restricted to the field of robotics. This is something that is valid across domains.